So today, because it's frigid, freezing, and miserable outside, we're going to do a workbench project. So let's roll the intro and see what we can do. So, saved this one out of the scrap bin at work. It's a natural sound stereo receiver RX-550 RS. I quite like the Yamaha series of natural sound receivers. I've listened to a couple of them previously and they have a really nice warm sound to them. And I figured, what the hell, right? It's free, so why not? Let's see what happens. For all I know, it works. So let's hit the old power button here. And we got a whole lot of nothing. We got a click of the main power relay. And that's it. Absolutely nothing else. So, let's pull it apart and have a look. Well, you got your main transformer, pretty bare bones looking circuit board all around. Nothing immediately looks wildly out of place except for the fact that the main fuse here is missing. 4 amp, 250 volt. Let's start there. So I forgot to hit record on this one, but I popped a fuse in it and it just blew immediately when I turned it on. So we have a short, a dead short somewhere in this thing. So we're going to have a peek-see around and see what we can find. There goes the power again. Yeah, the nice thing about older equipment is you can pop the bottoms off of them for servicing. I know, right? A system designed for serviceability, but a novel concept. You might even want to repair your old electronics. Something totally lost on manufacturers currently. Well, to be fair, it's not just them, it's also society as a whole, because when's the last time that you tried to have someone fix a piece of electronics for you? You don't. You just go buy a new one. Kind of a waste, really, if you ask me. There we go. And immediately, we see that someone's been here before. You can see here on these main power transistors, they've been resoldered previously. So, usually that's a good place to start, because if it blew once before, there's probably a chance it could have blown again. Could be a poor design, could be a bad set of speakers they had it plugged into. Let's have a look. Now, the initiated of you will know that you're really supposed to test components out of circuit. But I'm lazy, I don't feel like doing that. So we're just going to see what readings we have with them sitting in the circuit. I'm going to throw the old meter here onto resistance. And we're just going to probe around here and see what we get. So we got 2.79 and 37. There it is compared to the one next to it. 0.9, 0.6, 0.9. So those seem the same at least. Now these are attached, as you can see. These top two are just the mirror images of the bottom ones below. So in theory, if I swap my leads around, we should get 1.8, 0.5 ohms. So that's quite low on that one. 2.3 mega ohms. 2.3 mega ohms. So, just as a guess, for these initial and very unscientific readings, I'm saying that this guy has an issue. And we're going to pop it out and see what we got. The thermal pad's still okay. So what we got here, we can focus on it. Focus? No? Alright, well, you just have to believe me then. C3855130. So between pins 1 and 3 we should have continuity. Which we do. We should not have continuity between 3 and 1 in reverse. That's not correct. 2 and 3. Yep. That guy is blown. So, through the magic of the internet editing, we have here, admittedly a used set from eBay, but take what you can get. I bought a complete set so I could replace all the transistors and their complementary ones as well, just in case, because I didn't feel like ordering twice, or if I happen to blow it up, I get a second chance again. And as you may have guessed, I'm not an expert at this. I just do this as a hobby on the side, something to amuse myself and hopefully amuse you. Now, if we can just get this damn thing open. Yeah! And of course, there they all go. Okay, well. So now, before we go any further, I'm just going to confirm my diagnosis, because, you know, again, not an expert. Make sure my testing was correct. So between 1 and 3. Here we go. Not the other way. There we go. 1 and 3. Yeah, so the old one's definitely blown. 1 to 3, but not 3 to 1. That's correct. Should have continuity from 1 to 2. I believe in both directions. I could be wrong on that one. 2 to 3. We don't. Alright. Well, we're going to give it a shot. Just out of curiosity though, I'm going to turn it on without that transistor in there. I'm curious to see if that was the short or not. Oh. I'm going to put in some earplugs for this. Just because it goes bang, it might be loud. Which of course is fun for you guys at home, but less fun if you're standing here in person. Got a click. Haha, look at that. Have life. Well, we would have life if the power stopped flickering. Bet you thought I blew the circuit there, didn't you? So, now in theory, I'm feeding it a signal from my computer. I have the one transistor here still removed, but I should still get a amplified signal to the speakers. So we'll see what happens when I click play here. Well, better than blowing the fuse every couple seconds. So, unsurprisingly, we have a very distorted right channel because we only have one transistor in it. The left one, however, some distortion as well, but working. It's a start though. So, let's install our transistor and go from there. So what I'm going to do here is I'm going to bend the leads on my new one to match the leads on my old one. I'm also just going to give this insulator in here a little wipe. I don't know if you're supposed to do that or not, but it can't hurt. If it does, well, the thing was free from the trash anyways. So really, what's the worst that could happen, right? So we are going to sit this in here. And bolt it down. So we know that it's in place. Okay. And there's every chance that we plug this back in and it goes bang anyways, because there's something else wrong in the circuit that caused that transistor to blow. Yeah, no bang yet.
Searching for music for your next video? Then you need to check out our
I think the source of our distortion here might be a dirty selector switch. Yeah. Let's take that apart. You can hear it when I wiggle it. But, point being, it works 100% better than it did when we started. So let's have a look at that pot there. See what we can do about that.
There's some tape covering a hole here. What do we got in that?
maybe that's some access we can use to spray something in there to clean it up. Also probably help if I had a proper can of electronics cleaner. I don't advocate for the use of brake cleaner as electronics cleaner, but in a pinch. That should be CD. You got nothing. I plugged into the right input. I am. Why do we have nothing? Tuner works. Phono. That should be CD, I believe. Just check the old front panel here. Oh no, CD is that one. Let's see if our distortion's gone. I'd say it is. Wiggle the switch, much better. And we got both channels working now too. Left and right. There we go. So, having had this running now for 10 minutes, just sitting here at idle with nothing on or running through it, we're going to set the idle current. The service manual specifies that whenever you replace a power or drive transistor, which of course being the two main transistors on each channel here, one of which of course is the one that we replaced earlier, you're supposed to set the idle current. And you do that by setting the voltage between this pin here and this pin here for the left channel, and then this pin here and this pin here for the right channel. You set it to 10 millivolts plus or minus 4 millivolts using the little pot adjuster right here. So let's give that a shot now, shall we? You can't read my meter from where you are, but you're just going to take my word for it. Let's see what we're sitting at right now. Try to stay out of your way. So between, they call it TP1 and TP2. Alligator clips might make this a lot easier. So we're sitting at 8 millivolts, and we're aiming for 10 plus or minus 4. So we're in spec, but I think we can get closer. So now we go over to this transistor over here, and we go between TP3 and 4, which are these two pins here. And this one is quite a bit out. We're sitting at 6.6 and 6.7. So we're going to adjust that one. There we go. We now have 10 on the dot. Or damn close to it. Way closer than we were. That's how you set the idle current on these. Okay, it's all back together in one piece. Everything's adjusted and cleaned. I cleaned out the volume pot a little bit as well, just to see if that would take care of anything. Gave this one another couple spurts. Gave the whole outer casing a nice wipe down with a little bit of WD-40 just to get all the dirt off of the metal and make it a little bit of a sheen again. And now I'll give it a final test.